In this lesson, we will describe the locations in an aeroplane where smoke detection systems are likely to be used. Then we will go on to describe the various smoke detection systems in use, including the types of warning they give and how they can be tested. The areas on aeroplanes usually fitted with smoke detection systems are the cargo and baggage compartments, electrical equipment bays, and toilets. Smoke detection sensors operate on one of two principles. They are either optical, using light sensors, or ionizing, utilizing a small amount of radioactive material. The optical type of smoke detector contains a light source, the projector lamp, and a photoelectric cell. A photoelectric cell is a device which produces electricity when it is exposed to light. The greater the level of light, the greater the electrical current it will produce. The photoelectric cell is sitting in darkness. It is shielded from the light source's output by an opaque barrier. Outside light is prevented from entering by the light-tight louvers, but air can flow freely through the unit. If smoke enters the unit, it will scatter the light. This will cause some light to be seen by the photoelectric cell. The cell will now produce an output which will trigger an alarm. There is a test lamp in the unit. This lamp is positioned so that when it is switched on, some of its light will be seen by the photoelectric cell, generating a smoke warning. Ionization smoke detectors use an ionization chamber and a source of ionizing radiation to detect smoke. The ionization chamber consists of two plates with a voltage across them, along with a radioactive source of ionizing radiation. The alpha particles generated by the radioactive material ionize the oxygen and nitrogen atoms of the air in the chamber. To ionize means to remove an electron from. When you remove an electron from an atom, you end up with a free electron with a negative charge and an atom missing one electron with a positive charge. The negative electron is attracted to the plate with a positive voltage, and the positive atom, which is known as an ion, is attracted to the plate with a negative voltage. Opposites attract, just like with magnets. The control circuit senses the small amount of electrical current that these electrons and ions moving towards the plates represent. When smoke enters the ionization chamber, it disrupts this current. The smoke particles attach to the ions and neutralize them. The smoke detector control circuit senses the drop in current between the plates and produces a warning. The two types of detector, optical and ionization, both have advantages and disadvantages. The optical detector is very good at detecting low-heat, smouldering types of fire with lots of visible smoke. However, it is not very efficient at detecting high-heat fires, where the smoke particles are much smaller. The ionization type of detector has the opposite properties. It is very slow to detect smouldering fires, but quickly detects the smoke produced by high heat fires. Smoke detectors of all types can give false alarms if they are exposed to dust or dirt, or even the fumes from certain types of fruit being carried in the cargo compartment. Durians being a prime example. Ionization smoke detectors are commonly found in domestic units and aircraft toilets. Most aircraft smoke detectors, with the exception of those used in toilets, are of the optical type. One of the primary uses for optical smoke detectors is in cargo compartment smoke detection systems. Cargo compartment smoke detectors are usually fitted in pairs to help prevent spurious warnings, both detectors needing to sense smoke before a warning is given. If the compartment is large, a number of pairs of detectors may be used. A typical cargo compartment and smoke warning panel is shown here. We will go through the sequence of events which will occur in the case of an aft cargo smoke warning. If a pair of aft cargo detectors sense smoke, the red smoke light will come on. At the same time, the fire bell or chime will sound. The pilot will cancel the oral warning, then carry out the cargo fire warning checklist. In the particular system shown here, there are 2 cargo fire bottles. The pilot will raise the guard and operate the discharge switch to discharge cargo fire bottle 1 into the compartment. Operating this switch will also close off all ventilation into the compartment. When the bottle discharges, the discharge light will illuminate. If, after a preset period of time, the fire has not gone out, the discharge agent 2 light will illuminate. This is the cue for the pilot to once again raise the guard and discharge the second fire bottle into the compartment. It is a regulatory requirement that on aeroplanes with a passenger capacity of 20 or more, each lavatory must be equipped with a smoke detector system or an approved equivalent that provides a warning light in the cockpit or provides a warning light or audible warning in the passenger cabin that will be readily detected by a cabin crew member. If smoke is detected in a lavatory, a warning light will come on outside the affected lavatory. The cabin chimes will sound, and a warning will be given both orally and visually at the senior cabin crew member station. The oral warning can be cancelled, but the warning light will remain lit until the smoke has cleared and the reset button is pressed. That is the end of the lesson. Here is a summary of the main points. Smoke detectors may be fitted in cargo and baggage compartments, electrical equipment bays, and toilets. Smoke detection sensors operate on one of 2 principles. They are either optical, using light sensors, or ionizing, utilizing a small amount of radioactive material. Cargo compartment smoke detectors are usually fitted in pairs to help prevent spurious warnings, both detectors needing to sense smoke before a warning is given. It is a regulatory requirement that on aeroplanes with a passenger capacity of 20 or more, each lavatory must be equipped with a smoke detector system or equivalent that provides a warning light in the cockpit or provides a warning light or audible warning in the passenger cabin that will be readily detected by a cabin crew member.